All right. Good morning, everyone. Good morning.
Good morning.
Good
Hey,
morning,
how are you?
Professor.
Good morning, everyone. Good morning, Kazuki. Good morning, Angel. Well, so this is the last week. Everybody's aware of that, right? Begin Monday of the last week. Uh, we just have 1 week. It's not even 1 week because today is Tuesday, so we have 4 days today, and next Monday will be the last day. But practically, this week is the last week, so we'll have to cover everything remaining, right? Everything that's remaining within this week. So I would also like to. Uh, I would also like to take your attention to the results so far, right? Um, some of you may have noticed the results have been updated, right? Of course, the attendance hasn't changed since 14th because and if attendance hasn't changed, then, obviously, the, up this date, 17th, right? That would indicate the changed results of the test results. So if you open it, you will find this. I mean, we have 13 people on the roster, but practically, these two people are not participating at all. Haven't had any attendance. I mean, this person has only one attendance. This person, and they haven't. So they are still sticking to the. They're still on the roster, but practically non-existent. Now I sorted it by weighted average. The midterm results. Some people might have. Um, some people express disappointment. Uh, Disappointment, actually, uh, at their own performance. Uh, some some of you generally, I went through. I normally don't do this because during the regular semester because I have a large pool of students, but in winter, I have barely about 11 students. Um, so I basically regraded everything because the uh, the automatic grading is not like artificial intelligence. It can't. Um, the instruction clearly stated, to use, comma, uh, or decimal points. And if you didn't do that, there's no way. And some people just, if it is like 25 million, some people just put 25. And the grading system cannot automatically understand it as 25 million. That's why I had to regrade. Some of the some of the problems, some of the questions already had million embedded in the answer, something like dollar, million. So that means the answer is already in the millions. So you can just in that case you can put 25. But if it isn't like that, you'll have to either put 25 comma 3 zeros comma and 3 zeros, right? Or 25 million. I mean, think about it. 25 million. If you put million by word, it's a text. It's not a numerical value, and there is no way then the the algorithm can automatically um, consider that, automatically take it as numerical data. Then you get it wrong. So that's why I had to regrade everything, hand grade basically. Not only that, um, uh, some people didn't follow what I taught. It's mainly because I think it is because some people um, learned about time value of money from a similar class like accounting. But then in accounting class, they teach you the um, interest factor method, and this is wrong. Interest factor method. Um, I never taught you interest factor table method because interest factor table is um, it's an old method. It's an outdated method in the days before computer, and they had to rely on interest factor table. But I don't understand why accounting classes still use interest factor table. It's simply, um, trying to dumb down or dumb down people. Because if you use interest factor table, you don't think, you just follow the rate, number of years, and this is. But then there's a serious defect in precision because the interest factor tables have only like 2 digits, 2 decimal places, and if you have to use like three in the interest rate being shown there is just 1 digit, like 1.1, 1.2, 1.3. I mean, if you have to go to 1.25, 1.275, how can you handle that? And also, it only has like 30 years. Look, you can have, what if it is like monthly for 30 years? What if it is, right? It can't handle like something like daily compounding, monthly compounding, quarterly compounding, because the table goes only up to 30 years, right? In other words, it can handle only up to up to n being 30, right? Understand? Um, so there's a serious downside to factor table, and there's a lot of arbitrary decision that you have to make. For example, if you have to, if the interest rate is 1.725, I mean, factor table has only 1.1, 1.2, 1.3. How would you make that decision about 1.725? So you just, arbitrarily round it up to 1.8. Now that rounding would result in, then rounding error. You never think about that. People who use interest factor table never think about that. As long as the number is, look, um, if the rounding error is just like, very marginal, it wouldn't matter. I mean, it would matter very little. But if the rounding error results in, a significant difference, right? Just like, the difference between making a 550 monthly payment and making, $520 22 monthly payment makes a huge difference, right? So I never taught factor table, but some people used factor table. That's the only way I can explain it. That's the only way it can be explained. Why their answers were different from the correct answer. And that difference is the rounding error. And the rounding error is because they used interest factor table. That's not what I taught. I taught how to use, Excel, how to solve it mathematically by Excel. And then some people probably didn't even study that, or didn't even pay attention, or didn't even watch the main lecture video, or even uh, participate in the exercise we did in the during the collaborate session. And those, rounding errors, as I said, significant rounding errors cannot be ignored, right? So that's why, you had the result. Okay, I'm not going to dwell on this any further because we have only 1 week left, 4 days left this week. So we got to move on. Um, Now, also, I'm not going to go back to Euler's number because the main lecture has really expounded, right? Main lecture expounded it to great length. So I'm not going to go back to Euler's. It's going to take so much time, and we got to get started on, bond valuation from today. But since we didn't wrap up everything about the time value of money, I'm going to just go straight to the examples of how we solve for n, okay, and wrap up, time value of money quickly. So there was no question about solving for n in the uh, uh, midterm, but here, so to connect natural log to our problem, we had to uh, we had to discuss Euler's number because Euler's number is the basis of natural log. So here, so please, go back to the videos about Euler's number if you can't follow, right? And it is your responsibility, right? Studying is your responsibility, right? Lecture is my responsibility, but studying is your responsibility. And if you don't study, you're not doing, as a student, you're not basically doing, your responsibility, taking care of your responsibility, and you have no excuse for that. So, all right. So basically, this is how that formula is derived, right? We'll have to uh, the properties of log, right? I've been telling you. The reason we are using that, oops, this one is broken. Okay, fine. I don't need to use this. So here, right? Now, when we have log of something, right, raised to n, right, then we can bring this down, and then it can become n times log x, right? So then, look, by taking natural log on both sides, right, you have to do whatever you do to one side of the equation, you have to do the same thing to the other side of the equation, right? So then this becomes, what does that become? That becomes exactly z equals, that becomes z equals x, what's going on? That becomes z equals x times y pattern. And as long as you can bring any equation into a z equals x times y structure, right? You can solve any equation. That's the point of. So now, why does it continue to? So n is x here. So we can do, basically to find x, z divided by y. That's yeah, hence this result. So to solve for n, right? Here, let's go back to. Okay. Well, what's going on? Oh, why does it keep doing this? All right. All right. So let's do this first. Go to row 26, right? I hope you have all, you all have this file open. Go to row 26, and this is the same. We know already. It's basically same problem, right? 25 is about R. 26 is about N. So to find N, and of course we need to have R already filled in, right? Because otherwise, one equation, one unknown, one equation for one unknown. If you have two unknowns, you can't solve that equation, right? All the others must be given. So,
Professor, I'm
then,
sorry. Can you kindly repeat that one more time? If you have.
yeah. You must have only one unknown, one equation for one unknown, one equation for one unknown. Okay? If you want to solve for the one unknown, one equation, there should be only one unknown, because you cannot solve an equation with two unknowns or three unknowns, right? In other words, so far our equation is basically FV equals PV times 1 plus R. Now think about it. If you don't know FV, the other variables must be known. And if present value is the unknown, the other variables must be known. In other words, if there are four variables, right, three must be known, three variables must be known, and only one to solve for one unknown. Okay? And if you have two unknowns and you want to solve for two unknowns, then you need to have at least two equations. And then if that is the case, then that's called the simultaneous equation, right? Then you can solve for, when you have both x and y as unknowns, then you have to have two equations. But anyway, so if R is, think about it. That's why we had, we've had, compounding, which is, a future value, discounting, which is the present value, and then we had the formula for R, right? Compounded growth rate, right? R, and then we have equation formula for N, and in that case, the other variables must be known, right? So here, to find then, all we need to do is then natural log of, just like the formula, natural log of future value over present value, right? Divided by natural log of 1 plus r. There you go. We got exactly 20 quarters, and then we convert 20 quarters into years, simply dividing that by m. M is D26. So unfortunately, I cannot click it in because the formula is just hanging above it. So I manually typed in D26. So we got that. Let's try this here, right? First, this one is easy. I'm gonna let's do this first. Let's do this first now, which is a natural because it's just annual, right? It's it's not that difficult, right? And we'll get exactly 5. You should see natural log of 1 plus APR. We'll get exactly 5 years. But here, it's quarterly. We should also get 5 years. But first, we will get this. Then we'll have to make some adjustment. So natural log of FU, right? And then divided by natural log of 1 plus. Okay, but this will give us 5. Something like, it will be more than 5 because when APR was 24.57, it was 5 years. It's lower APR, so it should take longer. But we will need to convert it into quarters. So, but first, let's see what's. Yeah, I told you it's going to be more than 5. But then we will need to simply, because it's annual, right? We divide. I'm sorry. I got that. I should have made that adjustment here too. M is B21 is the annual rate, so I'm going to have to turn it into a quarterly rate. So D21. Okay, and if I do that, it's going to give us 20. But this is quarter. We know it's quarter, right? So we'll have to divide it by. What? D21 again. Right? Then that's going to bring us to 5 years, right? So in other words, I definitely believe you would prefer this because this takes less adjustment because adjustment is already done outside the formula, right? Now, so let's move on to the multiple cash flow model. Everything you've seen so far is called the single cash flow model. Why is it called single cash flow model? Literally, the examples so far, future value, present value, all this is based on a single cash inflow and single cash outflow and single cash inflow, right? In other words, I got a lot of, think about it. To have future value n years later, right? First, you have to deposit the principal, which is your cash outflow, right? That's your cash outflow. And n years later, you'll have cash inflow, right? So what happened? A single cash outflow and a single cash inflow. That's why it's called single cash flow model, right? But not everything is single cash flow model. For example, as an example, we talked about annuities. For example, future value of annuity. Future value of annuity, as an example, you studied this by main lecture, and so you did, the midterms. So I gave you this example. And annuity is not the only, multiple cash flow. Annuity is a typical example of multiple cash flow model because literally, look at the timeline. There's multiple cash flow, right? Multiple cash outflow. In our example, multiple cash outflow, and finally, one single cash inflow. Of course, this is an example of, ordinary annuity, an example of annuity due. And I told you in the main lecture, the difference between the ordinary annuity and annuity due is one more compounding. And it's the same thing also in the present value of annuity. The difference between the ordinary annuity, present value of ordinary annuity and present value of annuity due, the only difference is one more compounding. Actually, it is one less discounting, but one less discounting is the same thing as one more compounding, right? And one thing that people often confuse is that if it is, how do we tell the difference between present value of annuity and future value of annuity? They oftentimes, a lot of students have a hard time distinguishing between the two. How do we identify? Look, all the annuities are basically in the future. Annuity payments are, I think the main source of the confusion is that the annuity payments are all in the future. Yeah, of course, annuities are all in the future because if it is, nothing is in the past. Nothing is in the past. Okay? If it is in the past, that's not finance. I mean, what's past, there's nothing we can, what's already done, there's nothing we can do about it. I mean, you're not going to invest in a company that has already closed down, or you're not going to, I mean, whatever has passed, you either has already realized gain or loss, profit or loss. So all the cash flows are basically either in the present or in the future, right? So future value of annuities are all future payments, and future value of annuities, what's it going to be at the end of the timeline? And then present value of annuities, all the annuities are in the future, but the question is, what is it worth today? I mean, it's in the future. What's it worth today? So it's present value, future value. Exactly. Right? The future value of these annuities versus present value of these annuities. Right? So if we go to the Excel examples, one more thing. Annuity is just annuity is the main type of multiple cash flow model, but there is a case where uh, the payments, right, cash flows are irregular at irregular interval. Now annuities are basically payments at regular interval, right? Regular payments at regular interval. But think about it. There are non-annuity multiple cash flow. For example, you have, first of all, for the first, there can be a cash flow like, you're making payment one. Let me, or you're making a deposit at time 0, right? And at the time that interest rate was R1, okay? And then interest rate changes in year 2, right? And then in year 2, you make another deposit of P2, and then interest rate in year 3 at the end of year 2 would be so at the beginning of year 3, you make a deposit of P3, and interest rate in P3, interest rate in year 3 would be R3, and you can keep it for 2 years, right? And then you can make a withdrawal of P4 in year 4. And then in other words, there can be erratic pattern of deposits and withdrawals. And then, if that is the case, how do we do that? Well, there is no, in this case, this is just, a very tedious job. I mean, we'll have to keep tracking it like this. And then in year 5, you put, deposit of P5, you make a deposit of P5, and interest rate in year 5 was like R5, and in year 6 it's going to be a different interest rate. I mean, if it is like this is another example of multiple cash flow model, but this we are not, because it's just the tedious tracking of different deposits, withdrawals, and different interest rates. So this is not a meaningful thing. I mean, it's not undoable. It's just doable. It's just tedious and just annoying. We don't find any meaningful pattern here. That's why, as an example of multiple cash flow model, we do mainly annuities. Okay, so as an example of as an annuity example, where am I? doing? Let's do this, okay? This won't take much time. I want you to clear out everything there. Just clear out. All the highlighted cells, I want you to clear out. And all the highlighted cells. Okay, now let's do this. Did you delete all the highlighted cells? Everyone?
Yes, they're gone.
Okay, good, good. So now let's get started on this example. So this is exactly our future value of annuity. You graduate school example, right? You make a deposit of $800, and the deposit and regular deposit and payment. The symbol for that is just payment, PMT. They are simply two sides of the same coin. And the APR was 6%. Your timeline is 5 years. The graduate school fund, 12 and monthly compounding. The compounding gets monthly, and we know first. Okay, my keyboard. This I don't know why. Okay, so periodic rate. We know it's 0.5, 6% a year. I mean, think about it. If 12% a year, APR is 12% a year, monthly would be 1%, but it's 6%, so 0.5. I mean, you don't even need to use math. It's just logical, reasoning. Now, and of course, there will be 60 months, right? So 60 compoundings. And then future value of annuity, the formula is this, right? Okay, just take a good look at it. And so there's payment times, open parenthesis, open another one, because for 1 plus R, right, inner parenthesis. And then raised to n minus 1, close the outer parenthesis, divided by R. And there you go. Oh, we got the future value, but this falls short of our target. What was our target? 60K, right? You need 60K to fund your graduate school for for MBA program for 2 years. So it's still falling like $4,000, right? Short. It's falling $4,000 short. So you try out different scenarios. Okay, what if I save $50 more every month? Or what if I find a bank that pays higher rate, which is not easy to find, actually. I've been telling you, banking is a very competitive industry. They won't pay that significantly different rate. Or otherwise you extend your timeline to 6 years. Okay, but in all of those cases, you can just single-handedly, right? You don't have to. You can evaluate different scenarios in a single shot, right? Okay, now we come to this one is closest to our target, but still falling about $600 short, right? We're still $600 short. And the other scenarios, right? In the other scenarios, this one we overshoot the target, right? But that's not bad. I mean, you'll still have $9,000 after after your graduate school expenses. But then you cannot wait 6 years. Then this won't work. But if you can wait 6 years, this will work. Also, considering that the tuition doesn't increase for the next 6 years. we'll have to hold something constant, right? If you use future value of annuity due, I've been telling you future value of difference between the two is just one more compounding. So we do one more compounding, which is, so we can, recycle this result. One more compounding than ordinary annuity. So we do one more compounding. 1 plus R. Still we are short, right? Let's see. Still we're about, even with one more compounding, still about $400 short, right? So then the question is there a way we can nail the exact then monthly payment? Yes, of course. And I've, in the main lecture, I've shown you. Once again, the key is, if we can, I've been telling you, all equations, you can solve all equations as long as you can identify z equals x times y structure. And isn't this exactly z equals x times y structure? It's already presented in a nice, right? On a silver platter. It's almost, ready to eat, right? Think about it. So the formula is future value of annuity is payment times. You all know, although here it looks as if the payment is in the denominator, but it doesn't matter, because look, everyone knows that multiplying something to a fraction, when you multiply something to a fraction, you only multiply to the denominator, to the numerator. So it can be, split. Even if you write if it is, z equals x times y over w, right? It's only x times y over w, right? So if you break it up like this, then it's exactly, this is simply one term, right? Y over w can be, m, right? So we simply break it up like this. And then the just to save time, I'll abbreviate as the thing in the bracket, right? And then our unknown is payment. So if you solve for payment, then z equals x times y. So it's x is z divided by y. So FVA divided by the thing in the bracket. But again, we know dividing by fraction is the same thing as multiplying by the reciprocal of that fraction, right? That's just, middle school math. You divide something by a fraction, simply it's the same as multiplying by the reciprocal. And we know times, right? We know reciprocal is raised to -1, right? Properties of exponent. Something raised to -1 is the reciprocal, right? So then we come to and what's the thing in the bracket? Thing in the bracket is, FV over, 1 plus r times n minus 1, which was, numerator before. Now it's the denominator because it's the reciprocal. Now it's the denominator. And voila, that's the formula. I mean, it's not difficult. It's just middle school algebra. And textbooks generally, I mean, the reason I'm showing you all this is if you know how they are derived, then you don't have to memorize anything, right? If you know how they are derived, you don't have to memorize anything. None of the I don't know what finance class ever or accounting class doesn't even they're trying to dumb down everything, like just look up the table, right? If it is 1 point, they don't, and in the table you don't have even 2 decimal places. You have 1.1, 1.2, 1.3. I mean, think about it. Even by using 1 decimal place, you'll have to have 10 columns for 1%, 10 columns for 2%, 10 columns. So you would have to have like 100 columns. That alone is a huge table. So they don't they don't bother to go to even 2 to 3 decimal places. They just tell you to look up 1.1. Oh, is it closer to 1.2? Use 1.2. Then you end up in a huge rounding error, right? And then they never tell you how the formula is derived. They don't even teach you the formula. Accounting doesn't even teach you the formula. They just look up this factor table, interest rate factor, present value factor, future value. It's easy, isn't it? Look, and then you are becoming just nothing but a you can't think. You just become like a you don't know how the black box is built, so you can't fix anything if something goes wrong, right? You just feed the input into that black box, and out comes the result, and you just rely on it, right? These days, you have GPS, on the car. I mean, even like 10 years ago, there was a GPS, that came with the car. These days, you just plug in your phone, right? And you use, your phone's, like Google Map or Waze, Waze, I believe, Waze, for your GPS. The problem is when there is no reception, you're lost, right? That's the thing. When there is no Wi-Fi, when there is no network, you're lost. The thing is, the more people rely on GPS, then the more people cannot think, because you must have your mental map. Right? So that you can find your way. But these days, when you lose, GPS connection, then you're lost completely. So though, and even the textbooks don't show the connection between these formulas. So, and then the students, panic and ask me, Professor, do I need to memorize all these formulas? And I tell them, no, you don't have to. But even if I tell them, oh, you have to. Think about it. If you have to memorize all of them, how long will you retain that memory? Once the semester is over, they all forget, right? They all forget. So it's important to know how these formulas are derived, from the initial conditions, then you don't have to memorize anything. Now, we have this, so now we can nail it. So it's the same example. Your target future value is 60K. Target future value is 60K. So we'll need to, the unknown is the payment. So of course, this my Bluetooth keyboard is just like, this is because it's the cheapest one. We know periodic rate is 0.5. And then N is 60, right? There you go. Yeah. Now all you need to do is simply FVA times R over, open parenthesis, open 1 plus R raised to N minus 1, close parenthesis, enter. There you go. So we nailed it. We nailed it exactly. Monthly it is 859.97. So when we tried 850, we were still like $700 short. If you tried out 860, you will overshoot it by $2, which is not bad. But we want to nail it exactly. It won't be that much different. Think about it. When we tried 860, we overshot by $2. So it won't be that much different. So it would have to be lower than 860. So yeah, right? And then next, how do we find the rate? How do we find N? Okay, rate. So it's 12:55 already. So I think it's a good time to take a 10-minute break. We'll take a 10-minute and come back at 1:05. Okay, and then we'll just breeze through everything quickly, and then move on to bond valuation because we cannot wait any longer. All righty, so let's take a 10-minute. Okay. All right, we're back. We're back. Okay, so I see 7 people here in the collaborate, and I see 10 people uh, in today's forum. So that's like 3 people still missing. All right. Well, hopefully, they will be able to join us even, later. Now, so let's go back to, yeah. So our question was then, okay, just like, in the single cash flow model, right? We should be able to solve for every variable. And there are 4 variables in these equations, in these formulas, right? So this one, of course, this is, we already know this, right? What should be the payment, right? And of course, this is, I don't need to, no, I'm not going to do 11 to 13 here. This one, rate. What should be the rate? And this, how many quarters will, how many months will it take, or how many years will it take? We know the answer already because it's based on the same example, right? It should be 0.5%, so it should be 6% annually. It should be 60 months. Let's do a little different one. What if the rate was 7.5%, right? And, of course, we should be able to arrive at this 7.5. We should be able to arrive at, 6 years, So in this case, let's do this. So of course, first we'll have to find the periodic rate, which is, not difficult. Let's make it more interesting. What if, okay, that's fine, quarterly. And we know how many quarters? 4 quarters, right? If that's the case, the quarterly payment must be, and I'm not gonna, let's recycle, right? Copy the formula, right? If you copy, it's gonna be the formula, paste. Yeah, quarterly, that has to be $2,002.52, right? Everyone got the same result?
Yes. Yes, Professor.
Okay, good. Sounds good. Now, this one, let's find the rate. Now, unfortunately, right, there is no single unique formula for, finding rate in annuities. So in this case, we'll have to use Excel's built-in function, right? So to use Excel's built-in function, we go to function, right? And go for rate. I mean, if it was one of the most recently used functions, then it would show there. But if it doesn't, I'll go to financial category and scroll down. It's in alphabetical order, so you scroll down until you find rate. And then you give it what it's asking for. First, it's asking for n periods, right? So you give it n. There's no n just yet. I'm going to put it there later, but let's put it there. Payment. This is the payment. But here, the payment must be entered as negative. Why? So you put, minus sign. It's not really negative number. It just means it's the cash outflow, right? To use Excel's built-in functions, you have to follow the financial calculator convention. All cash outflows are negative. All cash inflows are positive. I mean, it's a common sense. Think about it. It's not that difficult to understand. It stands to the reason because it's the money, cash. You make this deposit, it goes into the bank, it leaves you It's cash outflow. But at the end of 5 years, it will come back to you. So it's, cash inflow. I mean, future value is the cash inflow. There is no present value. Ignore the present value because there is no present value in this problem because it's annuities, right? Future value, you enter this, right? Type means whether it is ordinary annuity or annuity due. And I've been telling you, if it is ordinary annuity, you just leave it blank. You leave it blank or enter 0. If it is annuity due, enter 1. And it's because I've been telling you, the only difference between ordinary annuity and annuity due is one more compounding, right? That 1 means there's one more compounding, right? And unless otherwise told, unless otherwise instructed, the default is always ordinary, right? Default is ordinary. That's why it's called ordinary. Okay, and then guess, you don't have to use guess. Okay, so you hit OK. Of course, you hit OK. G12, is it G12? Yeah, hit OK. And then you won't see anything. Why? Because this is missing. So all you need to do is do this. And then you get 1.88, of course. And then you convert. Final answer is, of course, annual, right? You give rate. Always, the rate must be always expressed as annual, right? So all you need to do is just times 4, right? Accordingly, right? Someone said something? This is the quarterly rate, so to convert it into annual rate, you must multiply it by 4, right? And then finally, finding n. Now, I explained in the main lecture how I derive the formula for n in. So there is, this is the formula for n in the future value of annuity. For present value of annuity, slightly different, but it's the same. You must use natural log, right? And these are steps of derivation. This is the conclusion, right? End result. Some students always ask me, Professor, do I need to memorize all that? No, this is not something to memorize. This is something you need to know by heart, something you need to understand, something you need to comprehend, because it's the steps of derivation. I mean, from this, it gets transformed. It transforms to this and transforms to this. I mean, it's just algebraic transformation, right? Finally, we turn it into z equals x times y format. So solving for x, z divided by y, right? So using this formula, right? There's no natural log of open parenthesis and future value divided by payment times, if you multiply something to a fraction, it gets multiplied only to the numerator, times r, and then plus 1, right? Wasn't it the yeah, and then natural log of 1 plus r divided by log of 1 plus r. There you go, and you hit enter. We got 24 exactly. So it checks out. I mean, 24 quarters. So then divide 24 quarters by 4, you'll get 6 years, right? You got 6 years. So once you're okay with this, then you can simply copy these, right? You can simply copy these. Once you copy this here, you'll have, exactly the same result. Once you copy this, right? And then, I would rather just simply, M 6%, and this divided by M will give you 5 years. Okay, now let's go to the present value of annuities, right? So this is our example. In our example, this is like lottery example, right? You won a lottery, right? $10 million, right? And then they will, if you win the lottery, of course, lottery is not a very common example, right? People generally don't. But if ever, the formula is this, right? After, if you choose lump sum, you will get, 6 million, right? They will take exactly, actually, top tax rate is 39%, so they will take out 30%. So, approximated as just 40%. But if you choose, annuities, you will receive, $20,000 monthly for the next 30 years. Then 30 years, right? Then applying that formula, right? Payment over R minus payment over, open parenthesis, R times 1 plus R raised to N. Close parenthesis. Don't forget to close parenthesis. Once you open the parenthesis, then you must close the parenthesis. Now, hit enter. Well, that's the present value of all those annuities. Now, here's the thing. Of course, then, if this is the case, then you choose the lump sum, because lump sum is already present value, right? It's 6 million. That present value is greater than, this present value. But it all depends on what is the interest rate. For example, 6% interest rate is only, a hypothetical. Reality is, interest rate is only less than even 1%. So if we use 1%, right, you drag it down, I would go for annuities, because the present value of the annuities is, more than 6 million. So I would go for the annuities, right? Everyone is okay so far? Now the second one.
Yes, yeah.
Okay, good. This is the car financing example. Remember that car financing example. And in that example, the dealership, you financed a car, something like a $30,000 car. So you made a down payment of $6,000. So the financed amount is $24K, right? And the dealership told you, monthly payment is $500. And then in this case, are we getting are we making the right payment? Correct? Is the payment correct? Or Is this a good deal or bad deal? You can tell, of course, by finding the present value of all these $500 monthly payments, right? Of course, to do that, we'll just, we'll need a periodic rate and N. So then I don't need to do it again. I'll just copy and paste it up. Now, then the total is, the present value of all those, payments are 25,862. So it's way more than 24K, which is your principal, right? So this is a bad deal. You're paying more than what you owe. And some people always ask, Professor, isn't that, what about the interest? I mean, doesn't it make sense that we pay more than, our principal because of it? No, we pay not by this, we pay by this. In other words, this is already including principal and interest, right? So, and this is the present value. In other words, this is the principal of all those $500. If this is the principal of all those $500, then obviously that is more principal than the principal that you owe, right? So again, we can find, also the present value, the payment. We can solve this equation for payment. We can solve this equation for rate. We can solve this equation for N. But let's. We're not going to do those today, but we're going to. We want to nail the exact payment. So if you want to nail the exact payment, so what do we do? So first, again, the formula turns into to solve this equation. The formula is this, and how it is derived. Think about it. Instead of trying to memorize, think about how you can derive it. How would I derive it? So you might wonder, then I must memorize also present value of annuity formula at least. Well, you can also derive it from the initial conditions, but that would, in the main lecture, I showed I showed how this formula is derived. But that's going to take too long, too much time, so I'm not going to do that. But at least if you're willing to memorize, at least this. Right? Think about it. There's a reason I put it in this format, because I'm not going to go over that. This explains, what is the main contribution of where it comes from, main contribution of R, what is the main contribution of N. I forgot to put N here. But think about it. You can simplify it further, because there are so many common factors. I mean, common factor is payment. There's even payment R is the common factor. So payment over R itself is the common factor. So we can factor out payment over R. Then this one will become 1. This term will become 1. But I will factor out only payment, right? Because payment is what we want. So if you factor out payment, the first term will be 1 over R. Second term will be 1 over R times 1 plus R to the N, right? And this second payment, what am I talking? And in the parenthesis, right? We can consolidate the denominator, because r times 1 plus r to the n is the what do you call LCM, largest common denominator. I mean, we can think about it. When you have 1 over 2 and 1 over 6, right? You can unify the denominator, right? This can be 6, I mean, by multiplying 3. And you have to do the same to both, numerator and denominator. So denominator became 6 by multiplying by 6. So then the numerator will be also 3, right? You can do it like this, right? That's basically, so that's what it is. Then this, I'm gonna, and think about it. Then this will become, 1 will become 1 plus r to the n. And nothing needs to change in the second term, right? Therefore, what is it now? We converted, now this is exactly z equals x times y format. Isn't it right? Z equals x times y format. Oh, come on. So then, if you want to solve it for x, then, and I've been telling you over and over, this is how you, no matter how complex the equation, as if you can reduce it to z equals x times y structure, right? Then you can solve anything, right? You should have a sharp eye to identify that structure. So then payment equals then PVA divided by this. Dividing by a fraction is multiplying by the same thing as multiplying by the reciprocal of that fraction. So this is the reciprocal of that fraction. 1 plus r to the n minus 1. Okay? Voila. So that's why, hence this formula. So again, you don't have to memorize, right? You don't have to memorize. You can, as long as you can, derive this, nothing to memorize. So here, then using that formula, right? We know it's gonna have to be 20,000 in both cases, right? Because we started from this, arrived at, okay, present value is already set as 6 million. I mean, if it is 6 million, what would, if you take lump sum of 6 million, if that's the present value of all those annuities, what should be the monthly payment? And then PVA times R 1 plus R times 1 plus, R times 1 plus R raised to n. Raised to n for R times. And also in Excel, people forget to put the operator like times. Look, algebraically, we can write without times, right? That's omitted. But we know human eyes can tell it's PVA times this, but the computer cannot understand it without, the computer will only execute whatever command you gave it to execute. So if you don't put the operator, it won't know what to do. Okay, and then at the bottom, it's 1 plus r raised to n minus 1. Okay, close parenthesis, and hit enter. Yeah. If then in that case it's going to be like this, and then you drag it down. If it is 1%, it will be like this. And that that conforms to our previous conclusion. If it is 1%, right? If the prevailing market rate is 1%, it's better to choose annuity, because annuity pays, present value of those annuities are greater than 6 million, right? If the present value of annuities are just 6 million, then it will be equal to the monthly payments of 19,000, right? So that conforms to our. And then here, if what should be the correct payment for the car, right? Well, we know then, if we only owe 24K, so if the payment is correct, the present value of the annuities must be 24K. So then setting this PVA as 24K, if we just copy this, all right, solve it, then it should come to 463.99, right? This is the correct payment. So they are ripping off, right? If they are, if you're paying $500, you're overpaying, right? Like $40, you're paying $40 every month for 60 months. Okay, so now next is amortization schedule. Now be careful. You see the row number jumped from 23 to 27. You see, so, you should wonder why. Because I just collapsed. I collapsed those columns, right? Rows 24 through 26. I just collapsed them because they are not. I don't want them to. They are not needed for this, and it's going to take a lot of space. So I don't want any space come between. So here, our amortization schedule and our payment information, right? So here, what is an amortization schedule? Amortization schedule is basically showing you how each monthly payment breaks down, right? Of course, it breaks down into principal and interest, but they don't break down into them in constant proportion. The proportion will vary. The proportion will change. Amortization is just how you pay back your loan, your debt, right, in installment. So think about it. Amortization is really an important issue, because in reality, nobody lends you money. Nobody lends you, $1 million and wait 30 years, right, for you to come up with $1 million plus interest, right? You got a $1 million mortgage loan, so you bought a $1 million house. It's a 30-year mortgage, and the bank doesn't wait 30 years for you to come up with, the future single cash flow future value at the end of year 30. No, that will never happen. Even, a small loan, right, like a car loan, the payment starts already the next month, right? The payment starts already. So that's how you pay back in most cases, and that's called amortization. So when you build the amortization schedule, then it shows you how that monthly payment breaks down into principal paid and interest paid, and it shows you the principal balance month by month, so that when you want to pay it off, it will you would know what's the remaining principal balance, right? Easily. And so here, okay. So your table is blank, isn't it right? There's nothing in your table, isn't it right?
We have all the data.
Okay, so then delete everything. Please delete everything. That's weird. I think I must have, oh, it could have, so delete everything. So did you delete everything? But leave the row 89, this row, leave it, don't delete it. When you delete the data, it's going to be automatically blank. So payment numbers, if you have already deleted it, no problem. If you have already deleted it, no problem. All you need to do is just plant a couple of, first series of numbers, the first, 3 numbers in the series. And Excel is so smart, it knows, what your intention is. If you're planting the seed of the numbers, 1, 2, 3, and Excel knows, oh, it's going to be a series of numbers with the interval of 1. So then if you highlight, if you select those 3 cells and drag it down, it's going to just generate the number series all the way to 60. When you see 60 in the small box to the right, you stop. Okay? And then, now, in the first month, your payment, well, this is your payment, right? So you enter 823, and then you must lock it. You know how to lock. Hit F4, right? Function key, F4. Okay? Then you'll see $sign. That means it is locked. Whatever is going to happen in this column, right? I mean, it is locked into 823. So 823 is locked. The value in 823 is locked. So that when you drag it down, it's going to be always 823. Because if you don't do that, if you don't lock it, as you scroll down, as you move down, right? This cell will point to 824. This cell will point to 825, 826. So in those cells, either blank or all different numbers. So you don't want that to happen. So, so everyone got this in column B, right? Everyone got the same thing in column B?
Right.
Okay, good. And in B89, it's the sum of all those numbers. So that means all of the monthly payments, 60 monthly payments, sum of all of that is this. So you're actually paying the interest, right? You understand? Some people were, I said before, some students were saying, what about the interest? I mean, can we just pay 24K? I mean, that's only the principal. No, you're not paying only the principal. What I'm saying is the present value of all of these 463s, right? Present values of all of that must be 24. But sum of all of that is 27K, 27,839. So interest, you're paying the interest, right? Interest is already included in there. Now let's think about the interest paid in the first month. So this payment must break down into interest and principal. So how much of this is interest? Some people say, oh, interest rate is 0.5% a month, so it must be 0.5% of this. No, it's the 0.5% of 24K. Because think about it, you're paying the interest on the principal. And in the first month, the principal is 24K. So it's 0.5%. Also lock that because it's going to be the same thing every month, right? It's going to be the same thing every month. And then times, right? You hit enter. So out of this monthly payment of monthly installment of 464, 120 is interest, and the principal must be the difference between the two. Isn't it right? It's only a logical thing. Must be the difference between the two. And then the principal balance must be, look, after the first month, you paid this as principal. So this 24K must go down by as much as this. Isn't that right? So at the end of the first month, right, 24K will go down by this. There you go. In the second month, you might think, oh, okay, so I'm going to repeat the same thing in the second. But no, not without making adjustment. Why? First, E23, yeah, that's correct. G24, what's in G24? There's nothing in G24. And after the first month, the principal balance is principal remaining is not 24K, but principal balance is not G24. It is this, right? After the first month, there you go. And this will automatically adjust. And what about this? Principal balance will go down, not from G24, but from this E29, it will go down by as much as D30. Make sense? Then from there on, it's you're home free. Just select those three cells, drag it down, and stop here. Okay? And think about it. Val, what is this? So yeah, this is
At line
is
88,
hmm?
drag it down to line 88.
Yeah, row 88. So let me so freeze pane, right? If you freeze pane, then the row and column labels don't change. You can scroll down and you see if you drag it down all the way down to row 60, and principal balance, you will see principal balance must be 0. Think about it. After 60th month, after month 60, your principal balance must be 0. You have paid off. You have paid all the principal, right? The principal balance must be 0. So it checks out. If you see 0 there, it checks out. Also check out row 89. A cell D89. Now what is column D? Column D is basically principal paid. And D89 is the sum of that column. The sum of the principal paid. And the sum of the principal paid must be exactly equal to 24K. Isn't that right? So we came to 24K, so it checks out. You paid off all the principal, so the principal balance must be 0. Right? Interest paid, sum of all the interest paid is this. So if you add interest paid and principal paid, it must be equal to the sum of the principal. Yeah. Sum of the payment, right? Exactly. This is exactly, right? Interest paid plus principal paid. So it all checks out. So everyone got the same result. Everyone got the same.
24,000. Yeah.
Yeah. Good. Yeah. If you got the same result, you're okay. You're good. So at first, this is this will take time, but once you get the hang of it, then you can build 30-year mortgage amortization schedule in just 2 minutes. Not even 2 minutes, less than 2 minutes, right? It's going to be 360 months, right? 30-year mortgage, 360 months. You can build amortization schedule, and then so a lot of people when they come by a large sum of money, they want to pay off. For example, you keep making these payments, but after the month 12, you came by a large sum of money, and you're tired of making monthly payments. I mean, if you use auto pay, it's gonna you're not getting bothered. But if you really make payment by check every month, you get it's annoying. But you don't want to do that anymore. So you don't want to, or you don't want to pay interest anymore. I mean, think about it. If you pay off after month 12, you're not going to pay interest anymore, right? So what's the payoff amount? This is the payoff amount. But of course, in reality, it's going to be slightly more than this. Like something like $20. Why? There's some, administrative transaction cost, administrative fee. I mean, they won't do this for some fee, administrative fee. So, but it won't be big. It won't be like hundreds of dollars. It will be only about $20 at most. Okay. Any questions so far? Any questions? Any questions?
No.
All right. That's you're just speaking for yourself, but what about the other people? Hmm?
Yeah, no, good here. Yeah, thank you.
Okay, all righty. Good. So all right, then it is almost 1:50. It's 1:48, but it's right about time to take a break. So let's take a 10-minute break, and when we come back, we'll go into bond valuation. Bond valuation. We've been doing all these annuities because of bond valuation. So let's take a 10-minute break and come back at 2 o'clock. Okay? All righty. Let's take a 10. All right, we're back. We're back. So I have six people, in. What happened to the rest of the? I just hope they are coming back soon. So we're now moving on to topic 4, bond valuation, and I'm not going to talk a lot about because I'm not going to go through everything because we already did a lot about. We talked a lot about bond valuation already in the previous topics. Like in the first topic, we were in ROI. We talked a lot about bond valuation. So we're gonna first before the bond valuation, let's first take a look at the bond quotes in the print media. This is how the bond price is quoted in the print media. And it's showing the typical three bonds of the three typical bond issuers: Treasury, corporate bond, and municipal bond. And in the first column, Treasury shows the coupon rate in the first column. However, in the first column, they don't show any coupon rate. It's just the name. And then they show the coupon rate in the second column. And in the first, in case of Treasury, right? In the second column, they show the maturity, right? Month, year, February 13th, and N. What is that N? I'm gonna get to that later. And then corporate bond and the municipal bond, they show the maturity on in the third column. And then in the fourth column, they show the price. They show the price. And however, Treasury shows, price in two ways: bid and ask. And everybody would, anybody who ever bought something on eBay or sold something on eBay would understand what bid and ask means. Bid is the price that the buyer is willing to pay. Ask is literally the seller asks for, right? The seller asks. So bid and ask. But the interesting thing is, what is that? I mean, $104.25. Huh? What's the and what is that column? I mean, if it is $104.25, then why don't they use just the decimal points? Why it is colon? So it's not decimal point. It's clearly not. Okay, sorry about that. It's just the duster, right? Compressed there for there was so much dust on the keyboard, so I just used compressed air to get rid of the some dust of various. Anyway, so it's clearly not dollar price. If it is dollar price, first of all, $104 is that even realistic price? First of all, it's not dollar price. And in the fifth column, Treasury shows the change in price. But in the fifth column, corporate bond shows yield, and then sixth column, Treasury and municipal bonds show yield in the sixth column. Okay, Another thing is look at the price of the corporate bond and municipal bond. Are they only about $90, 91, 97? Is that possible? I mean, is it realistic? I mean, the bonds are, what's the face value of the bond? Anyone? What is the face value of the bond? Anybody? Do you remember? I mean, we just did it.
1,000.
1,000, yes. If the face value of the bond is 1,000.
Professor, can you hear me?
Yeah. Who? Yeah, I can hear you.
Oh, just making sure. Okay, never mind.
Yeah, I can hear you. Yeah, 1,000. Yeah, that wasn't that long ago. We talked about this, right? Was that Yang, right?
Yes, yeah.
Okay, Yang, you're getting 0.5 for that. So think about it. Is it mature? And look at the maturity. February 2013, May 2016, and June 15th of 2037. I mean, so this one, municipal bond, hasn't matured yet, but all the other bonds have already matured. I mean, they were already matured in the past. They already matured in the past. And the reason these examples were taken actually in around June of 2010. I didn't take these examples. I just took a picture of the page in the textbook. Does the textbook say that the examples were in 2000 as of 2010? No, textbook didn't say that. I could figure it out by calculating n, right? So according to that calculation, these examples were taken in around June of 2010. So then think about it. As of June 2010, right? This Treasury had only less than 3 years left, and corporate bond has about 6 years left. If it had, like, Treasury had less than 3 years left, that means, you're getting $1,000 in less than 3 years. And how can that, something like that, trade for $104? Huh? That's ridiculous. I mean, only 2 years later, I mean, just about 2+ years, 2 years and several months, you'll get 1,000. Something like that, shouldn't it at least go for something like, $800 by now? Huh? And about the corporate bond, in 6 years, you're gonna get 1,000, but it's selling for $91 today. Does that make sense? I mean, is it rational? Is it, rational? Shouldn't it be trading for at least something like $600 at least? So we come to the conclusion, yes, this is not dollar price. So what is it? It is percentage. Prices are expressed as percentage of the face value. So that means this corporate bond is 91.73% of the face value. So that's actually $917.35. Okay, so this is how bond prices are quoted in the print media. The prices are always quoted as percentage. Both, online media or print media, it doesn't matter. This is how it is, quoted, how the price is quoted. And then, so this means 97.57% of the face value. So then, you might say $975.70. No, Why? Why not? Because the face value of the municipal bond is different. What is the face value of the municipal bond? Anyone remembers?
5,000.
5,000. Yes, municipal bond has $5,000 face value. So you get another 0.5 yen. Municipal bonds have 5,000. So the price is 97.57% of 5,000. So you can calculate it later. But then what's still a mystery is what is the columns? So is it 104%? 104%? 4.25% of 1,000? Then it should be $1,400 something. Yes, it's right. This is also percentage, but so it should be $1,040 something. But the numbers behind the colon is not 0.25. It's not 25%. It's not 0.25%. It's actually 25 out of 32. 25 over 32. In other words, they use Treasury uses 30-second system. 30-second system. Okay. That means numbers after colon represents 30 seconds of 1%. So a beta 104 colon 25 is 1,000 times 104 plus 25 over 32 of 1%, right? The calculation is, it's not that difficult. $1,000 times 1.04, right? Okay, I gotta put I forgot to put the parenthesis. Put the parenthesis. Ay. It doesn't clear, so I'll have to clear everything. 1,000 times open parenthesis 1.04 plus 25 over 32 times 0.01. 0.01 is 1%, right? And then there you go. Hit enter. Yeah, $1,047.81 to 5. 81, right? Rounded to, So this is how you convert. And this was already all explained in the main lecture videos, so I'm not going to go over it anymore. 2.75% interest rate means, you're getting 2.75% of $1,000 a year. So, and the bond pays, I've been telling you, bond pays interest semi-annually. So every 6 months, 13.75. Okay, and the N in the at the end of the maturity indicates that the bond was originally issued as a 10-year note, right? Treasury note. And I explained this earlier when we were on ROI. The bond can be born as Treasury note, 10-year note, but as the time goes on, if the maturity is less than 1 year, if the maturity left 9 years have passed and the maturity left is less than 1 year, then it is traded as Treasury bill. Okay, Treasury bond, the same thing. 30-year, it was born as 30-year bond, but 20 years have passed. It has less than 10 years left to maturity, then treasury bond is traded as treasury note. Okay. So I'm not going to go over this anymore. I'm going to go straight to, okay, first, go to municipal bond. So okay, let's think about the tips. Go to tips first. Tips is Treasury inflation protected securities. Now think about it. 2.75% yield. I mean, yield is lower than that. 2.75% coupon rate is really low rate. Annually, these days it's not even 1 point something, but 1.5 I would say. But think about it. If there is, you will know if there is even 2% inflation, right? The interest is already losing 2%. I mean, your real interest rate will be only 0.75. What if the interest rate is, if the inflation is 3%? If the inflation is 3%, this coupon is even 2.75. Real interest rate is even negative 0.25. So Treasury becomes very unattractive instrument. So they came up with tips. It's basically making adjustment. They are making adjustment to the par value by the inflation rate, right? By as much as the inflation, par value is adjusted. So the interest is also adjusted, because if par value is adjusted, inflation is. So inflation measured by CPI, Consumer Price Index, right? As par value changes over time, what that is, no, par value doesn't change over time. Better, this is the wrong verbiage. It should say, as par value is adjusted over time, adjusted over time, right? Delta means change, as par value is adjusted over time, interest payment also changes. So at maturity, at terminal time, investor receives inflation adjusted par value. So here, take a look at this example. Consider a 10-year TIPS issued on January 15th, 2007, paying 2 3/8% coupon. Of course, this is also like, treasury way of, we can convert it into a regular percentage, right? 3/8 of 1%. So like, that's 2.375%, right? It's not a big deal. CPI for these bond is 201.66. So that was as of January of 2007. CPI was 201. What that means is, so here, time, January, right, 2000, and CPI at the time was, what was that? 201.66. And then 2010, I believe, 3 years later, January of 2010, CPI was 216,246, so 216.25. Okay, so then think about it. What was the inflation between these 2 years? First of all, CPI, base year of the CPI is 1984, right? Base year is 1984. I don't know which base year this, because these days, another reference point for CPI is also 1997. And for a long-term macroeconomic CPI data, the base year is 84. It's actually, not exactly 84, but it's like 82 through 84. And so 82 through 84, CPI is 100. Okay. And why? But 1984 was like, 40 years ago, right? Almost 40 years ago. So sometimes, using 1984 as the base year, there's an argument, there's so much, it's when you have such a long time horizon, you don't have, the average, the mean of a long-term horizon would become a very neutral number. So if you want to avoid that, neutral mean reversion, you use 97 as the base year. But the main point is, the main reason they use either 84 or 97 is because those were the years they had recession and bottomed out. So in the early 1980s, there was a huge recession, and that was, artificially induced recession to cool off the economy. The stock market is cooling off because currently the Fed has announced that they're going to raise the rates, but then again, it wasn't unexpected. It has already been priced in, but the market is behaving very, as if, the market is not doing very behaving very badly, or market is showing very so much weakness, not because, once, it's always before the FOMC meeting, they always show this pattern, but once, either after the FOMC meeting, it rebounds, always, either whether it is more expansionary policy or contractionary policy. Once everything is certain that market rebounds, it's gonna be the same thing. Now, so regardless of whether whether it was 1984 or 1997, but just between these 3 years, we can tell the inflation. Was it 201? It's not 201. Oh, 216. I'm sorry, 216. Jesus, no. 216. Okay, the CPI roughly increased by just, roughly 16 points. But, in percentage, that would be like 8%. Isn't it right? Why? Any growth rate is the same thing. 216.25 minus 201.66, right? Over 201.66, right? You can do this later, but it's roughly 8%, right? Because it's 16 over 200, 16 over 200. It will be less than 8%, slightly, but roughly 8%. So the whole point is then, we will adjust the par value by 8%. So here, between the 3 years, par value will be, it's actually, 7.231%, right? The inflation is 7. Right? So if you adjust it by 7.231%, it will come to $1,072.31. So then the coupon payment will be 1,072.31 times 2.375%, right? And then half year, that will come to something like, $25, something like 25 something. And half year, you divide it by 2. It comes to 12.73, right? So this is how you adjust the coupon payment in tips. Okay? The calculation is not a difficult thing. Simply, you can use, 1,000 times, what was 216.25 divided by 201.66. It was 25, but I somehow I made a typo, right? We'll come to this, and then times 0.27. What was the rate? 35. 2375. 2375. Yeah. Oh, something's not right. It should be again. Not 10,000 times 216.25 divided by 201.66. Okay. Times 0.02375. Yeah, $25.47 divided by 2, because that's annual coupon. Divided by 2, you come to 12.734 something, right? So this is how you make adjustment for tips. Okay, and then municipal bonds. We are out of time. I think this is already 2:33. We're going to talk about municipal bond tomorrow, and hopefully, get to the even finish up everything about bond tomorrow. Any questions so far? Any questions?
Sir, you'll have office hours for the next half hour or so, right?
Yeah. I will have office hour. So you need office hour. If you need, then just stay on, right?
Okay. Yep.
Don't log out.
Sure.
All right. If there are no other questions then. No other questions. Let's call it a day. I'll see you guys. I'll see you guys tomorrow at 12 noon. Have a great afternoon. Take care. everyone.
Professor, do
Yeah.
we have the quiz 2 recently?
Yeah, you're gonna have it soon because quiz 2. Once we cover everything about the bond and the first part of first risk and return, then quiz 2, and then okay.
Okay, got it. Thank you, Professor.
Alrighty.
Good day.
Leslie, you have
And
a question?
yes,
Yeah,
Professor. Will the
Mhm.
finals be Monday or before Monday?
It will start before Monday, but it will end on Monday.
Okay.
Okay. Alrighty. All right. So I'll see you guys tomorrow. Stop sharing, and I will stop recording. Okay. But I'm not signing.